folks, to another edition of Expanding Mind. I'm your host, Erik Davis. As the sounds of Mark Pilkington's soundtrack disappear, we dive into another domain in the cultures of consciousness. One of the challenges and excitements about living in our extremely peculiar era is trying to come to terms, which of course we never can, with the enormous productivity of the sciences today, and particularly where they relate with technology, neuroscience, and the changing models of how we communicate, both on a physiological level and on a technological level. And all of this productivity, of course, is very, very, very hard to track, even to get a sort of overview of or a glimpse of, a decent snapshot, and if one is not a practicing scientist, you kind of sometimes think of scientists as being like all together, over there, like across a river or something, and you're just sitting there like going, hey, what's going on over there? And then you get these news reports on the RSS stream or the front page, as we used to say, and you're once again reminded of this tremendous kind of productivity. But then the more you actually know about science and how it's actually done, scientists, you are a scientist, you realize that, for the vast majority of people doing their work, they're also kind of confused because they're channeled often into a very narrow spectrum where they're concerned with like the enormous literature on one particular receptor site, on one particular kind of neuronal cluster, and that's their work, and that's where they do their research, and they can barely map other things in neuroscience, let alone what's going on in, physics or, new materials, et cetera, et cetera. So everybody's kind of in the same boat, and we all have to come up with our ways of managing this. If fascination, obsessive following of science writers, ignoring it as much as possible. There's all sorts of ways, but there's no stopping the fact that science is an extraordinarily powerful determinant of not just the way our society works, but the way that we look at ourselves, the way that we look at our minds, our personalities, and those aren't just abstract ideas. They are also technologies, practices, drugs. They manifest in things that actually change the way we interact with the world and with ourselves. So one of the ways I like to do this is to just find those interesting people out there who have, for whatever reason, a really great angle on this stuff, whether or not they're scientists or observers of science, and just, keep the conversations flowing. I'm a big fan of the idea that one of the ways you deal with the chaos and turbulence, really, of our current moment in terms of trying to understand what's going on in the world is to really cultivate those connections, personal connections, conversational partners, who offer a unique perspective that you can't get just by trying to follow the news or even, good newspapers or magazines. And for me, one of these people has for a long time been our guest today, Carlos Seligo, is an old friend of mine and who has been for 15 years, I think, the academic technology specialist or has been working in technology with professors at Stanford University and has been working for a while in the program in human biology. So he's kind of like a renegade humanist has had a front row seat, literally, at a cutting-edge research university and has some very interesting observations to make about science, the future of the mind. And so we'll be diving into that. It should be a great talk. But before that, of course, we'll bring on our co-host here on Expanding Mind, Maja Daou, the White Witch of Los Angeles. Hey, happy equinox.
Yes, indeed, to you as well.
I can feel the powers shifting. The juices are changing their orientation in my body as we speak.
It's that time of year.
you're going to be doing something, some equinox-like celebration coming up soon, right?
I totally am, yeah. I'm going to do a big event over at the Del Monte Speakeasy in Venice. I'm going to do a spring equinox ritual that's going to be based on Astara, which, of course, is the pagan goddess where we get Easter. She's the one that the church decided to rip off to have Jesus get resurrected. And we're going to have like 8 bands play. It's going to be ridiculously epic.
So it's not so much a kind of like healing woo thing as a rave it up, rock in the new phase kind of thing.
Yes, we're going to have a dance-a-thon.
That's an excellent way to bring up the old ones.
Yes.
All right, well, let's bring on Carlos Seligo. Carlos, welcome to Expanding Mind.
Am I on?
I believe you are.
All right. Hello.
Hey, and you're calling from Santa Cruz?
Yes.
Excellent. So, I thought one place to start is just tell me a little bit about this kind of interesting sort of job you have, because it gives you a really interesting angle, and has for many, many years, on what's happening on a kind of day-to-day level with the sciences and research. But you kind of got into it from an interesting angle, from a humanities background, and I think that'd be a good place to start.
All right. Well, as with most careers, it looks like a little bit of an accident in retrospect. So I can't actually explain how I got here, but I am the person who supports faculty teaching and research in the program in human biology at Stanford. And it is itself a very bizarre program that was founded in this utopian late 60s moment where the chairs of 7 departments, psychiatry, everything, biology, future presidents of the university all wanted to reform education. And they basically just wanted to create a place where the disciplinary restrictions would not limit the object of research. And there's lots of objects like global warming, a lot of things in evolution or neuroscience and psychology that are drifting and bleeding into other disciplines. So they've had a very productive 40 years. And it's because so many problems don't belong only in one discipline. They were a place that the teaching of those interdisciplinary subjects thrived. And I do things like, a faculty member wants to, one of the faculty members I support the most is a senior researcher. She's the head of synthetic biology now at NASA Ames. And they do things like they want to figure out how you could make something like a cheaper light with a microorganism instead of using power. Or how could you, Craig Ventnor, who was the person that a couple of years ago created the first kind of artificially copied bacterium. He basically put together the base pairs in a 1 million base pair long genome of a bacterium piece by piece, and then inserted that into another kind of hollow bacteria and got it to live. It's a very Franken moment. And their dream is, we could beam these to Mars at the speed of light and then synthesize them in a printer there. That kind of far out, realming what will happen in the next 20 years research, for some reason, happens a lot at Stanford. And you get to see the students that get told these things first. And I'm there often, and it's really exciting.
Well, so you've described it to me a little bit sometimes as being like you're almost like a kind of secret humanities person. They all think you're a neuroscientist or something, and so you have this a really interesting kind of inside-outside perspective, and particularly at a place where, as you say, they're willing to go for the far out and really try to imagine big. So. One of the things that I think is really helpful, and one of the things I'm always aware of when I talk to you, is just how can you illuminate a little bit about what's actually going on in at least the sciences that you have a perspective on that kind of isn't necessarily what people would think. I mean, I think sometimes even for those of us who follow the news and try to keep up with sort of the big issues, the Higgs boson and whatever, that we even though we get a lot of information, we don't really get a sense of how science actually works, and especially now with technology and all the breakthrough informatics and all the kind of stuff that's happening. So what would you say that you kind of learned about how things work in a way that is illuminating and that you might not have understood before you really had your gig?
Well, one thing that comes up all the time is that a lot of scientists who read about their own research in the news or hear about it somewhere else or go on a talk show to talk about it find the public reception of it is so at odds with what they're actually doing that they kind of just smile and assume there's no way to solve the problem. It's very strange. Usually they're only upset about it if something like is misconstrued, but it just, what most scientists are doing is they're in some narrow place where they want to solve a problem that has consequences but requires very careful practices to ensure that the question they've asked will have evidence that matters. It's all like, can I construct this experiment that when I get a result, I'll move forward in the terms that a scientist considers forward? So for example, I'll just give you one that's kind of like far out at the same time as it requires evidence. The more radical the proposal you have as a scientist, the more carefully you have to prove it, right? So in this astrobiology class I support, we review, the amazing discovery, I think it was 15 years ago, of a Mars asteroid in Antarctica, which appeared to have fossils of life on it. So some people will really remember this and others will have never known this happened, but it was like a matter that went to the president. And the guy that researches this found a couple things that sort of are good evidence for it. One of them is that in Japan, I think it's Mitsubishi or I don't remember which company, has spent over $1 billion trying to synthesize artificially this thing called magnetite, which is basically like the compass that bacteria use to navigate. Incredible as it sounds, they literally have little pieces of metal that are responding to the magnetic field, and when they spin, they steer. And there's no way to make that magnetite at the incredibly small scale that a bacteria can make it artificially. Nobody's figured out how to do it. And it turns out that this Mars asteroid has magnetite on it. So if you found this in your backyard and you said, oh, this had to have been created by a living bacterium, nobody would dispute it. But when you find it on a Mars rock, you got to do a little more. So nobody can explain how that is in there, but it also would have to be corroborated by other evidence. So, for example, the fossils that would look like Martian bacteria are kind of too small by Earth standards. They'd be too small to have a genome in them, so they're probably not. Or, all these questions come up. And for 15 years, scientists will push and push and push, trying to resolve these unresolved questions, like, is there life on Mars? But even, is there life in our atmosphere? Is there life deep down in the crust? And you have to really not just find it once, but reproduce it and have other people find it before people will call it, like consensus science. That's really a good example right there, because I think that the outcome now is basically they don't believe it had life on it, and yet there's very important unsettled issues about how some parts of the Martian asteroid could exist.
You work a lot with, people who are studying exobiology and the sort of ideas of life in space, which is pretty trippy stuff. What's some of the things that you're excited about or that you're involved with now that that sort of again give us a sense of just how far out, really, from a outsider perspective, some of this research is, or some of the questions they're asking?
Well, this is a great moment to talk about this, because just yesterday, Lynn Rothschild, who's the professor of this astrobiology and space exploration class I've been supporting for 5 years now, I guess, she had her final, and some of her students did presentations on their own kind of pet topics. And she's very, she believes the scientific imagination is what motivates us. So she'll try to get us to imagine the moon used to be, 15 times as big in the early era of the Earth because it was closer and it's been drifting away. She's like, imagine the moon giant in the sky with huge tides, that kind of, science fictional viewpoint is something she tries to inspire in her students. So her students made those kinds of, you probably know this from Carl Sagan being auto-tuned, but they made their own mashups from available NASA and, Discovery Channel and other video. And they always have in the background Neil deGrasse Tyson talking about how, the most astonishing fact is that, our atoms were created in the crucible of exploding stars, this kind of far out science ideas. And they made their own. And everybody was watching them kind of like, it was reminding me of like a religious moment, because there's no reference to an external transcendental being, but it's as though the actual facts of the physical universe are more far out than any miracle that was ever invented by man.
Well, that is just a marvelous way into, I think one of the interesting things when you think about, the relationship between science and religion, and people think that, science colonizes the space that religion used to have explanations for, and then, religion tries to figure out where it has a role, if it has any, and then, spirituality comes along, and all this kind of stuff happens. But one place that one keeps coming back to when you think about what is it, like if I'm talking to a very hard-nosed scientist, somebody who's like not at all interested in any kind of supernatural explanations, not interested in meditation experiences, whatever, is invested in a scientific view, reductionist, and even the one place where he and I can often, or she and I can often meet, is precisely in the sense of cosmic awe, the sort of like wonder, the shocking, amazement that it takes sometimes hard for us to sneak up on it. It's hard for us to even make it happen sometimes. But all of us at times in our life, it just the fact that things exist, the fact that time is as long as it is, the fact that the stars, are just, splayed before our monkey eyes at night is just extraordinary. And then there's this kind of feeling. And that feeling for a lot of scientists is actually a motivator. I mean, it actually is kind of like the equivalent of a religious experience. I might be cruising along, doing whatever, and for whatever reason, this happens to lots of people, they have what we would call a religious experience, or an extraordinary experience that is explainable to some degree with religious language, and often changes people's lives or changes their motivation. Science, it seems like this weird place where, some scientists, not everybody, but a lot of them are like somewhere along the way they manage to have these kinds of experiences, and then they channel them into their, oftentimes sort of tedious and very difficult, time-consuming, laborious kind of work. And so do you see a lot of that? I mean, do you have the sense that a lot of what's driving, particularly something with dealing with astronomy or dealing with off-world kinds of activities, that a lot of people do actually have this kind of awe, this kind of Carl Sagan, almost like wow, man, kind of thing going on beneath all of the technical work and the specific questions they're asking?
Yeah, I mean, see, here's the point where the scientists just sort of would start to smile, because, if a religious experience makes you enter a monastery and spend 60 years, practicing the Vespers every day at a certain time or whatever, that's going to look just as boring as titrating, solutions for 40 years to try to verify some small fact. So it's really hard. I don't think scientists consider their research as dull as other people do. So I'm going to give you another really quick example. My director for my program has spent a long time, half her life, studying these Mormon fritillaries in the Colorado mountains. And it's something small, like, if the metamorphosis into the butterfly phase happens a week earlier than not, there's less plants, and it's coming a week earlier because the snow melt from climate change possibly is changing some environmental factor, and they'll study this in incredible depth over years and years, and they'll finally have a datum. 82% of the decline in the population of a butterfly can be accounted for by snow melt. And that is, that's like Newton inventing the calculus. It's like incredible at that moment. And I don't think other people tend to, sploogie over a solution to a math problem. But if you do, there's no difference emotionally between that and the feelings we have when you see eternity in a flower, or whatever the classic romantic religious experiences are.
Well, and that's a really good example, just to use that William Blake line, because it's actually, like what Erik was saying, when these scientists get so involved in this isolated, reductive kind of process, trying to get into a singular thing, just figuring out the genome strain of a single, bacteria, that if it's true, all those religious mystic ideas, I mean, if you figure out that one thing on a little level, it applies to the universe. It applies to everything, because everything is contained in like a single thing. So it is, to me, it's a lot like kind of figuring out the whole universe when you can figure out one of those little teeny tiny things, because it translates. It goes from microcosm to macrocosm.
You know, there's a Nabokov line, I'm going to mangle here somewhere, but he basically said that scientists try to, you know, he was a butterfly expert in addition to being an author and a poet. And so he said that basically scientists are trying to find everything about one point in space for all time, and poets are trying to find everything about all space in one time.
Oh, that's good.
So, you know, he put it better. But basically, when Blake is looking into the flower, he's not trying to understand its genome. He's experiencing that flower in a way that embeds him in an eternal moment. Like the difference in time is no longer relevant. So
right.
That expansion of the mind, whether it's in time or space, are I think they're very hard to explain if you haven't had them.
Well, and that's where, like in Taoism, right, the whole Lao Tzu thing, he says, like, if you know one thing in one moment, you know all things in all time. And so it's a very, actually, funnily enough, the religious philosophy that the scientists are really kind of going after when they're looking for these minutia things.
Yeah, I think the thing is that this becomes a problem with people who are spiritual and talk about an institutional religion or those differences too, is that it's as though there's all this stuff that the scientists would see as extra. So they don't even enter into the debate about whether it's religious or spiritual. That's just sort of like off topic. It's hard to explain. So let me tell a different example, actually, that's come to mind from this astrobiology and space exploration class. There's a guy named Rusty Schweikert, who was the Apollo 9, one of the crew of the Apollo 9, which is the Apollo the one before Apollo 9, I think it was 8, went actually around the moon and came back without landing. But Apollo 9, they're testing all the phases of the landing on the moon. And they had to test whether they could get out of the command module and get back in case there was a jammed hatch. So in Earth orbit, if you ever see a picture of a Apollo module, command module in Earth orbit, the only time it ever happened was on Apollo 9. He got out and did an EVA. And he's basically, got like a little wire, and he's got all of his life support on his back. And he's hanging on with one hand on the outside of the module. And Dave Scott, I think it was, who was on it, was going to videotape, or at that time, just 16 millimeter film him doing it for the engineers, and his camera busted. So he said, you've got 5 minutes to fix the camera, and there was nothing to do. It's like the only freedom we have in life is canceled meetings. And so he sort of let go with one hand, and he looked out at the Earth, and it's a blue ball. He describes how he's like floating inside the suit, and he can't hear the life support because it was surprisingly quiet. And he just has that 2001 experience. And it's actually, I kind of gave Erik a link to this. It'd be worth the audience playing this. It's only a few minutes. Now he's, a man in his late 60s. And he basically says, who am I? Why am I in space? What are we doing? Is it me? He has this whole weird kind of Buddhist collapsing of the ego moment where he says, I'm just this guy from Jersey. A million things could have happened where I woke up late in the morning and I wouldn't have been selected. It's not because I'm the most excellent that I got to this position. One person had to be the head of the train in the movement out into the frontier of space, and I'm it. And he basically, literally describes it. He's been talking about it for 40 years as this kind of cosmic birth of Gaia. And all the terms he's using go against the expected terms of, I think he's an astrophysicist from MIT who was trained to be an astronaut who follows minute-by-minute protocols written out by mission control. Yeah, and in really, 5 minutes, he did the whole thing.
Yeah, it's extraordinary moment. It said that the lecture is on YouTube, and if you kind of follow this step, everyone's really aware of Edgar Mitchell, who has this famous experience where he's essentially kind of consciously practicing a certain kind of trance state on his return from the moon in the early 70s, and he has this extraordinary cosmic moment that then inspires him to kind of go off and be like a New Age figure and start a New Age institution, and up in Petaluma in California, the Institute of Noetic Sciences. And he tells his story often. It's sort of one of these classic stories in the kind of New Age, because like, look, even an astronaut, will become interested in telepathy and parapsychology and all that kind of stuff. But in a way, Rusty's account is more interesting because you can tell there's nothing leading up to it that he has any intention for this thing to happen. And he's also using technical language right up to the very minute that he starts describing his experience. And it's not even just that he realizes the kind of marvelous absurdity that he, as this kid from New Jersey, winds up being, a spaceman looking at the Earth with this kind of cosmic eye, but that he was also sort of everybody, and he emphasizes the way that his sense of the eye had expanded to, in some sense, include the Earth, and at that moment he can't help but see this kind of cosmic narrative with powerful religious overtones of sort of moving into space and transcending the Earth and getting a wider view and all that kind of thing. So it's a really marvelous reminder of how I think one of the problems that happens when people talk about religious experience is that there's a difference between what I call extraordinary experience and religious experience. And they may look like the same thing, but what happens often is that people have extraordinary experiences, but they are either predisposed to think of them as religion, or after the fact, when they're scrambling around trying to explain it to themselves, they find that religious language is very helpful and illuminating. But the experiences themselves often are more untagged than that, and it's a more complicated relationship between our thoughts about religion or spirituality and the kinds of experiences that we have, which opens up the whole question that you and I have talked about as well, about what neuroscience can tell us about these effects. Because you have I think you say that there's even a name for this this kind of big cosmic picture effect inside of some neuroscience. Am I right?
Yeah, I hope I don't mispronounce some of this. I learned so much from reading. But there's a professor, Andrew Neuberg, who's for years tried to study something he calls the overview effect. He studies people in MRIs that meditate too, so it's sort of his home turf. Several people do this. It's actually somebody in the Midwest that's the real, let me get a bunch of, Tibetan Buddhists into an MRI and see how their brains work differently. But he's one of them. And there's a phenomena they call the overview effect. And I frankly have this in an airplane. You look down over Sonoma and you go, look at all the cute cars. Everything on Earth is just fine. And you forget about the opposite view where you're like, we live in the worst of all possible unjust worlds, right? So there is probably something about looking down that provides you an abstract, heavenly viewpoint. And the experience of Mitchell and Schweikert and others, people have these experiences skydiving and stuff too. They want to find out, like, okay, does the temporal lobe begin firing at a different rate during this? They want to find some physical evidence, probably because as all science that becomes applied works, then you could actually induce it, right? And you could say, well, let's just turn this thing on whenever we want to and give you an overview effect in a pill. But basically, the overview effect affects a couple parts of your brain in a way that resembles, or possibly affects the brain in a way that resembles ecstatic or balanced or harmonious states of meditation. And there's this thing called BOLD. I'm going to get what the acronym is wrong, but it's something like blood oxygen level dependent detections of functional MRI. And they can basically tell where the blood's rushing in the brain and then say, this is the blueprint of a brain that's loving. This is the blueprint of anxiety. This is what depressed brains look like. People have probably in some way or another run into these pictures of the brain at this point. And if you study people meditating, you can see different brain patterns in higher and higher fidelity as we're going along. Every year there's a way of doing it like a whole new, better resolution, or in time at higher resolution, like get a sample every half a second instead of every 5 seconds. And it opens up an interesting question that if you could get a perfect picture of what's happening in the brain, would that provide us with a perfect model for the, elusive mind that we assume emerges from the brain?
All right, that's a great question, but we're gonna take a break now, so we're gonna come back to that after the break. You're listening to Expanding Mind with Erik Davis and Maja Daou. We're talking with Carlos Seligo, technology specialist at Stanford University, and we'll be right back after this.
Welcome back to Expanding Mind on the Progressive Radio Network. This is Maja Daou. We're here with Erik Davis, and we're talking with Carlos Seligo about life in outer space and science and stuff like that. Before the break, you were talking about looking at the brain overviews and stuff like that, and it's so funny because there is that palpable consciousness shift where you can see things. It's like, when the pictures of the planet Earth came out, when those were first released, and there was this kind of like everyone had this consciousness shift by looking at it in a totality, that looking over it kind of thing. And when we look at brains in much the same way, you can kind of see it in this totality, in this overview. And that, to me, again, is a lot like scientists looking at, bacteria, looking at what is like a cell and that kind of overview thing. And since we're talking about, kind of astrobiology and stuff like that, what do you think is that significance of, instead of trying to get to some answer by getting into the overview of like a bacteria on Earth, trying to get into it like in terms of outer space, because that's like kind of the opposite, right? The looking up instead of looking down. So if we tend to spend a lot of time looking down at the overview, well, have you like kind of run across anything in terms of like the upper view?
Well, this actually was a question a student asked of Rusty Schweikert. It's so funny. He always says, "I have a life," because people have been asking about something that happened 43 years ago. He has this whole Association of Space Explorers thing where he goes to testify to the UN to try to increase research to have ways of preventing asteroids from hitting the Earth. And it's like a totally different project he's involved in for 20 years, and nobody really cares as much as they do about this mind-blowing thing that happened to him. So a student asked him this. He basically said, "I know you don't want to talk about this, but when you're up in space, are you more impressed by how small you are above the Earth? Or is it the difference between you and the Earth, or the difference between the Earth and the universe?
Right.
Which distinction are you focusing on?" And he didn't hesitate for a minute. He was just like, "Oh, it's the Earth and the universe."
Yeah.
And it's basically because this beautiful blue ball is surrounded by limitless death. I mean, there's no other really way to put it. Like the vacuum is toxic. It's radioactive. Everything out there is really not conducive to life, and everything on the surface is. And so there's this kind of like, oh, how precious this is moment. Same thing when they watched the moon rise over the moon. It was like, look at this lifeless moon and look at our place. We're going back. And that's kind of right on the cusp of what you're talking about. So when you look up from Earth, you can be, Kepler imagining the celestial bodies or that kind of thing. But if you're actually exploring it, you start to feel the chill. The romanticism of space is very different from an engineering perspective.
Well, and so what about like that in terms of life on Earth and the origins? Because I read Francis Crick's book, What is Life? And he kind of gets into, DNA may have come to us from somewhere else. And some of the implications of, like you said, when that meteorite from Mars lands on Earth and we can see that there's other life, there is that like, oh my God, look at all this death out there. But then there's also, well, what if we come from out there and there's some other source of life out there that maybe we can get to through the like darkness, So what are some of the implications to you of getting like kind of beyond that to some like bigger origin, past the emptiness of it, to some other kind of source of things?
Well, there's a man named Louis Alamandola, who's also at NASA Ames. He's like a down the hall other research scientist from Lynn Rothschild who teaches this class. And he comes and speaks about astrochemistry every year. And it turns out that the newer telescopes we have that Spitzer, there's a couple of them, they basically can use like the telescope has to be at like 1 Kelvin, like almost absolute zero to work. And they have a variety of infrared spectrums they look. And if you look in the infrared at, say, that part of the scabbard in the Orion constellation where they've seen the birth of stars. They're all, they're only 1 million years old, which is like 2 seconds in astronomical terms. And they can actually see that the gases are being illuminated as these stars are coming online. And they can detect what's in the gases. Because the gases are basically
of the color.
The star fart. It's everything that got blown out. And it's floating and it recondenses to make the next stars. And in that gas, there is amino acids. There's all kinds of, they're called polycyclic aromatic hydrocarbons. But these kind of vibrating, it's like a hexagon of carbon atoms that are also found on Earth. And they're raining down on our atmosphere all the time. So we don't need to make those on Earth. When you try to imagine the transition from the physical to the living, which is actually the hardest jump. It's probably a harder jump to imagine in evolutionary time than even the emergence of intelligence.
Right.
The hardest thing is how did the first little RNAs start copying or proteins? And a lot of the material that's required in the cell machinery is just floating around in space. So precursors are everywhere. Amino acids, all kinds of things. And we used to not know that. We didn't even know there was anything more than a little bit of nitrogen. There's all kinds of stuff. And we're getting, comet-like house-sized boulders of ice flying into the atmosphere all day long. So these things are being brought in. The theory of panspermia that was basically, Lord Kelvin was the big advocate of it, although things go back to ancient Greece about this, was that somehow the universe is fertile and it's seeding life. There's a tamer version of this where they want to determine whether or not a spore could survive at the right depth inside of an asteroid where it's warmer and protected from radiation. Could it travel all the way from Mars to Earth and potentially seed it? Because it's not going to go in a straight line. It might fly around for 1 million years before it lands. So you want to know, could something be preserved that long? Could it survive re-entry? And the European Space Agency, more than us, is really actively studying each step of what would be necessary to determine if that's possible. And, if there was life on Venus or Mars at one time, and they're constantly being bombarded, why not have a piece of it knocked out and hit the other planet? Just like we, Monsanto corn accidentally gets into the neighboring field.
It's very much like that.
I want to go back to that discussion of the view of Earth in space and that kind of that cosmic affect, that overview effect, because there's a couple of interesting things to say about that I've thought a lot about. One is just where the sense of cosmic awe comes from. And like you say, a lot of people from the Earth side look up and it's this kind of like romantic sublime, this sense of immensity of the sort of, otherworldliness. But it often has, and people often describe it as being this kind of, delicious feeling of wonder and amazement. But of course, it's terrifying as well. There's the true sublime, at least in the traditional romantic sense, comes along with a kind of sense of terror and a sense of finitude. And you can go back to, I think, one of the places I like to think about it is through Pascal, who's sitting there. He has this great line about the terror before the infinite spaces, because once people started to realize that the universe was not just a set of balls tucked inside one another, but was actually an infinite or something like an infinite. Whether or not it's ultimately infinite or bounded is a kind of almost a different question. That there's also this sense of a kind of terror, a kind of like, where are we? A kind of these infinite spaces are also frightening. And if you go through literature and science fiction and early fantasy, you can find the terror along with the awe, and in fact, they kind of feed one another. And it's always been interesting to me to see the way that we have a kind of secular idea of religious experience by the amazement of the universe, and it's you have to go a little bit farther into science fiction and into more talking about whatever dark side cosmic thinkers to go like, yeah, but it's really frightening as well. And so when I imagine that view from space, when I imagine seeing the Earth as this tiny little fragile, a jelly bean against this ferocious, infinite, hostile, toxic void, I got to figure that some of that that powerful emotion does come out of a kind of tenderness, a kind of sense of fragility, and even a bit of fear. And that leads me to the question I have, which is that we forget sometimes, but when those images from, I think it was Apollo 9 that the first image of the Earthrise over the moon came back.
8.
It was 8. Okay, so when that image came out, and at this moment in the late 60s, and people are, what's the future of the world? It's a whole sense of revolution, of transformation, of fear, of crappy things going on. It was a very epochal moment that this icon became a really powerful image, and a lot of people really believed, almost in that kind of 60s way, that just by sort of seeing this image, it would help us to develop a planetary consciousness, a sense that we are not just individuals, not just people who belong to one particular nation or one particular religion, but that we're actually all together here on this very fragile ball, and that would help, create a kind of planetary consciousness that would solve problems. Didn't really happen, I mean, maybe a little bit, certainly it's part of our experience, but, certainly didn't happen on a mass scale. But it sort of seems like maybe it's just that a photograph can't do it. Maybe you need to really be there. And you and I were talking about, one of the things that some of these, private corporations who are looking at the possibility of private space travel, that obviously, I mean, there's a lot of people out there who would spend a lot of money just to have, 3 minutes floating up there. And it makes me wonder, what's going to happen when, if we go that way, that all these wealthy people, they're not going to be Joe Schmo. It's not going to be, your third grade kid's, teacher. It's like all these heavy-duty characters are going to go up there and have this moment, and then you're like, well, gee, that might actually make a difference.
This came up in the presentation yesterday. One of the students pointed out that Ashton Kutcher just reserved as the 500th person for Virgin Galactic that, 6 minutes in space you're only up at low orbit, but you're weightless. And she said, if any of you got the cheddar, buy one now because you'll be on the same flight.
Oh, God.
There's 6 or something on each flight. And, I don't know, probably somebody in that classroom had $200,000 for 6 minutes in space. But, rich people have always had the best drugs.
Well, it's true. Well, Erik, I just wanted to say, too, that's an important thing to point out. It's one thing to look at a picture of it, but then another thing to have the experience, right? It's like the difference between watching a porno and having sex. There's a big difference. You can imagine it, the picture opens your imagination to it, but you can't, look at the ocean and expect it to be the same as, going swimming in it for the first time. So, I mean, it's untranslatable almost, It's almost like you have to be there and have the realization that he did and have it come over. You can't, I mean, people get fascinated maybe and stalk him because of what he said, because they're chasing out, well, how was it? How did you get there? What was it like? But then, I don't know, can you even get anywhere near that just from hearing a description or looking at a picture,
and also we with Google Earth, I remember, in the early 90s, I went to a kind of electronic arts festival, and somebody had this kind of globe where they had projected images from satellites onto the globe, and you could move the globe around, and so you could kind of and I control it, and it was really striking because it was simultaneously kind of sublime and also kind of creepy, like a game. Look, now you can screw around with the planet like you screw around with a computer mouse. And with Google Earth, it's the same thing. And I mean, it's extraordinary. And I've spent untold hours going and looking at Mongolia and the Grand Canyon, and I mean, it's totally amazing. And yet there's something about, as it becomes incorporated into our technological hyper-mediated reality, the bloom goes off the rose. And sometimes I wonder whether part of what's happening to astronauts like Rusty or Mitchell, Stryker or Mitchell, is that it's just the sheer novelty of it. And that if you have Virgin Airlines going up there and people going out, okay, now it's your time for your, where you float, look out the window. It's like, and then people are recording it, and then we have, more and more sophisticated cameras where we can do like remote viewing, like I can plug into it and actually look around, and it's like I'm there, except I'm being mediated through a camera. That being there that you're describing kind of disappears, but I'm not really sure why that's the case, or if it's the case.
I'm just always struck, and this may be from being an exhausted parent, but I'm struck by the extent to which modern existence is divided between two very different things. On one hand, this morning I accepted a ton of soil and gravel. I dropped a kid off. I made a lunch. I did a zillion things. I fixed a bug on Drupal CMS. I made a radio interview. I'm like, we're all like fried. We're scattered in every direction experientially. And then at the same time, our secret bliss is some kind of thrill seeking. Like we're going to have some ultimate experience that's going to somehow organize the disorganized nature of the rest of our experience. And I think religion traditionally has mediated between the two of these in a way that didn't require us to blow our mind. And it's strange that we even have these objectives. It's like, the next iPad is going to make me even more... There's this very strange confusion of religious experience with thrill-seeking that emerges inevitably, maybe only in California. But I guess I might ask the two of you about that, because I don't think that most scientists' idea of thrill-seeking, which they do want, is like that. Their sense of thrill-seeking is, oh my God, I got significant data.
Well, that's a very interesting observation, because really, if you look at where do people get religious experience, it's usually through extreme crisis, right? I mean, people will get to religion because some messed up stuff happens that forces them to either confront mortality, or they'll like have a close call. They'll almost die usually, and that's kind of where religion steps into the picture. So that kind of thrill-seeking, like adrenaline junkie thing, I think goes hand in hand with the religion, because you get like that, your heart starts to go, and then you're like, oh my God, what if I die? And then you start thinking about that, and then religion comes in. I think it's the same with the scientists, where they're like, oh my God, like what is going to happen? And a lot of them are driven by some kind of experience with this like kind of thing, and that's what really kind of gets them going.
I think another way of thinking about it is that one, if we just take it's so easy to talk about religion in general, and it's like you get lost, like what are you actually talking about? But one way of looking at a practice that both occurs very much in a strongly capital R religious tradition and in this sort of more spiritual but not religious world of seeking religious seeking experiences and intensities that you're describing is meditation. And one way of characterizing what meditation can do, and of course there's many different kinds of meditation, is that it increases your ability to experience the moment itself as a kind of fresh, pure event. We go through our lives, and a lot of that sense of the kind of fragmentation and even tedium of adult life is because we're just running on models that we've kind of developed, and it's just easier neurologically, psychologically to run on models. And one of the things you can look at when you start studying people who are advanced meditators and you're putting them in brain machines is you can see that they respond to certain signals with less routinization. So, and it certainly feels experientially like with that meditative mind, you are able to experience the ordinary as extraordinary. And so if you look at that thrill-seeking side, the crude version is that, okay, I just have to do more. I have to do extreme sports, or I have to take lots of psychoactives, or I have to have, 4-hour orgasm. Like, I'm going to push the sensorium to a point where it becomes ecstatic and something is revealed. But in a way, the ordinary practices of religious life, to some degree, and I think more explicitly with meditation, they cultivate your ability to actually find in very ordinary moments that kind of sense of the extraordinary. That, in a way, it goes back to the Blake thing. It's just a flower. It's just that flower. Could have been that one. Could have been this one. no big deal, lots of flowers out there. Sure, they're cool, but lots of flowers out there. But what is the mind that is able to see, infinity in that particular flower? It's not quite the thrill-seeking mind. It's not quite. It's actually, in a way, closer to the mind, I think, of the scientist. Just the scientist gets it mediated through data. But when they're actually seeing, like, this is real data out of which something like a fact or a testable claim about how the world actually works is possible. In that moment, there's a sense of insight, or there's a sense in which the world itself has revealed itself. There is a kind of revelation, but it's often in the minute. It's often in the flower. So I do think there are ways in which religious experience or religion in general can cultivate those more ordinary, extraordinary moments, as opposed to what often seems to me increasingly as I get older, a kind of unhealthy fixation on big, extraordinary, crazy experiences that I think people get kind of hooked on as a way to deal with the fact that most of life is very ordinary and often tedious and confusing, and one thing happens after another, and you're not in control, all this kind of thing. So it's actually, I think, an interesting way to think about how that scientific mind and the meditating mind, share something in a way as well.
Well, ideally, we wouldn't have to get, at $10,000 a pound cost into orbit in order to have these experiences, and you would get them from a stick the way my dog does. It's like, this is the greatest stick, or my son will just play with some bubble in the bathtub and he's just thrilled. So, discovery doesn't require that mind-blowing. It shouldn't, at least. So I just think it's almost like a symptom of, if you're trying to have an experience, and it's very hard to have an experience unless it's at that volume, there's something wrong.
Yeah.
Well, and I think that the main issue with that is that most people, it's like they can't perceive something unless it is at that volume, right? Because they're so kind of deadened, like Erik said, with the routine that their perceptions are closed to it. But it's once you kind of still and quiet down, and you can see that bubble and just see it for how beautiful it is, see the rainbows in it. It's a perfectly acceptable way to have that kind of mind-blowing experience, but I think it becomes a matter of perception and how open you are, really.
I think one aspect of that is that you're willing, as part of what you're cultivating as you cultivate a mind to have those experiences in an ordinary way, is that you recognize that the doldrums part, or just the hard labor part, or just the washing the table part, sets up the experience. It's like you need dynamics. The example just popping into my head is about sound. Like the way recordings are mastered these days. That pop recordings and rock recordings are mastered in a way where they're on 10 all the time. Like if you look at them on the VU meter, it's like they're always at 10, and they're at 10 because they're explicitly engineered to compete with all the other things that are on 10 that are, in everybody's environment now. Whereas, in earlier phases of recording, that would be considered terrible mastering of a recording, because what you want is dynamics, where when it's quiet, it's really quiet. And then when it gets loud, it's really loud. And the difference between them is what creates the possibility of whatever, pleasure or of a sense of insight into what's going on with the music. And in a way, our lives are like that. Like, we have to really be able to just be doing the boring thing, or the quiet thing, the slow thing, the same thing, in order for the novelties or the sort of glimpses to really emerge. But I think what most people do, especially now, is sort of fill it in because they're so busy, or they need to be distracted, they're addicted to distraction, or they're just busy because we're all incredibly busy these days. So,
Carlos, I'd like to kind of, I'm assuming we're kind of at the end, I want to make a little pitch
1 minute.
for scientists and encourage your listeners to imagine the subtle pleasures of spending years following this ritualized practice that has to be recorded and done exactly right, to conclude with a residue in the bottom of the test tube, which, changes the whole world. That weird attention to detail and focus where a small thing might make the largest difference is a regular feature of scientific practice. And that education and awareness of why something that small would make such a big difference is right at the heart of the whole scientific endeavor. It's why, I mean, whatever you think about science, you can't disagree that it's changed things more than anything in the last 400 years. I mean, it could be that in the economy or, one part of it, petrochemicals, but something has changed radically in the last 400 years that probably isn't how religion has changed. It's probably something in the economy or industry or science. And so just for that reason, if you're interested in your era, to know why scientists are good at focusing and find a small difference that has a satisfying effect, I mean, it's really, I don't know how anybody could not be fascinated by it. It's the most interesting thing that's happening.
That's wonderful, man. It's a great place to end. Thanks so much for being on the program with us, Carlos.
All right, thank you.
All right, from me and Maja to all of you, keep your minds open.